Hello, everyone. Today, I would like to walk you through how improved the performance of our classifier, how we evaluate it, and strengthen its fit, and how we aligned the final model with real business objectives in a loan approval context. Rather than treating this as a purely technical execute, we approach it as a decision-making problem where model performance must translate into financial value and risk control. To improve the classifier, we begin with figure engineering because the model quality is fundamentally constrained by feature quality. Instead of relying only on raw variables, we design higher level features that better capture the meaningful relationships in the data. We created original risk indicators by combining related health or behavioral conditions into composite scores. This allowed the model to recognize the cumulative risk rather than isolated sign signals. For example, multiple moderate risk factors together many indicated higher differential probabilities than any single one alone. By summarizing these effects into structured features, we string signal clearly and reduce the noise. In addition, we engineered the interactions terms to capture nonlinear relationships. Real-world financial risk rarely behaves literally. The impact of one variable often depends on the level of another. By including interaction effects and applying transformations to skewed variables, we allow the model to learn more complex decision boundaries. This enhancement improved class separately and lead to a measurable increase in F1 score. After strengthening the feature set, we compared the multiple models. We begin with a logistic regression because it provides interoperability and serves a strong baseline. However, its linear structure limited its ability to capture complex relationships. We then tested the random forest, which improved performance due to its ability to model nonlinear patterns and the interactions automatically. However, it showed signs of mind overfitting and did not produce a strongest validation result. Ultimately, we selected a grant boosting model as our final classifier. This model provided the best balance between bias and variance, handled categorical variables effectively, and delivered the highest validation of the effort score. Although it is Scruffy some interpretability compared to logistic regression. It produced the most stable and accurate predictions. From a business perspective, this improved F1 score reflects a better balance between identifying high-risk borrowers and persuading profitable lending opportunities. One of the major changes in our whole dataset was a class imbalance. The majority class represented the higher risk borrowers, which are the most important cases to detect accuracy. To address this, we implemented class weighting during the training. This ensured that the misclassifying monitoring cases carried greater penalty, improving recall without certainly harming precision. We deliberately choose class weighted over purely systematic oversampling techniques in order to preserve the original data distribution and maintain probability collaboration. We also conducted systematic hyperparameter tuning by lowering the learning rate and increasing the number of boosting interactions. We improved generalization performance. We adjust the tree complexity and the regularization the strings to reduce variance while maintaining predictive power. After turning the validation F1 score improved, and the gap between training and the validation performance narrowed, including better bias variance balance. Another key improvement involved the zero-hold optimization instead of using the default probability cutoff. The open file we performed a fine granted zero-hold search to maximize validation F1 score. This adjustment is critical in a low-approved setting for positive approving a risky borrower. Can result in financial losses through default, a false negative rejecting a credit-worthy borrower, resulting in lost revenue and reduced customer growth. By shifting the zero-hold upward, we reduced the unnecessary approvals of risky applicants while maintaining a reasonable detection of safe borrowers. This step ensured that the model's outputs aligned with the business risk tolerance. To assess the model fit, we implemented a stringent training validation split to preserve class proportions. This produced a more stable performance estimates compared to a simple underfitting behavior. The training performance was slightly higher than validation performance, but gap narrowed as datasets increased, suggesting the manageable variance rather than sort of overfitting regularization and thoroughly further stabilized the model. We also evaluated the confusion matrix and the precision recall curve to understand trade offers more deeply. The confusion matrix helped quantify how many risky borrowers were correctly identified and how many safe borrowers were incorrectly rejected. The precision recall curve related that aggressively increasing recall sharp reduced the precision. Therefore, we selected a threshold that balanced the profitability and the credit risk exposure rather than maximizing a single matrix speedily. Second, in a production environment, we would implement continuous monitoring. We would track F1 score precision recall and probability distribution over time. We would also monitor feature drifting using statistical techniques to detect changes in input distributions. If the performance degradation or drift is detected, the model will be retained and rebrated. This ensures long-term robustness and protect the institution from flight modeling decay. In conclusion, improving our classifier required more than selecting a powerful algorithm. It involved therefore feature engineering, careful handling of the class imbalance, systematic hypermeter tuning, rigorous validation, and business aligned their hold, optimizing most importantly. Every technical decision was made with the financial implications so in mind. So a successful loan customer is not just accurate, it must balance risk control with revenue generation. Thank you guys for the listening.